Hello everyone, my name is Sadiq and I'll be talking about data warehouse deployment on AWS. So I'm gonna start with introduction. So as we all know, in today's world, that data and analytics are indispensable to business. Almost all large enterprises have built data warehouse for reporting and analytics purposes, using data from a variety of sources, including their own transaction processing systems and other databases. So we have a traditional data warehouses, which are kind of like difficult to scale. And like when data volumes grow or you want to make analytics and report available to more users, you have to choose between accepting slow query performance or investing time and effort or on an expensive upgrade process. In fact, some IT teams discourage augmenting data or adding queries to protect existing service level agreements. So, and in most cases, they are often forced to either upgrade hardware for a managed system or enter a protracted negotiation cycle for an expired term license. So, and based on these topic that I'm talking about, we have Amazon Redshift that has changed how enterprises think about data warehousing by dramatically lowering the cost and effort associated with deploying data warehouse systems without compromising on features and performance. So we have Amazon Redshift that is fast, so like you can easily manage it, and so it has a capacity up to like petabyte scale data warehousing solution, and so it is pretty simple and cost effective to analyze large volumes of data using existing business intelligence tools. So with these Amazon Redshift, you can get a performance of columnar data warehousing engines that perform massively parallel processing, so at tenth of the cost. So yeah, as a small business owner, you can easily upgrade to Amazon Redshift to take care of your data warehouse. And so even a large enterprise as well can easily do that. So it just depends on the capacity that you actually want. So that the time is your price. So you can actually start with $0.25 per hour with no commitment and scale up to like petabyte for $1,000 per terabyte per year. So, and this is pretty good, and so it makes things easy for both small scale enterprise and large scale enterprise. So, um, and right now I'll be talking about the history of Amazon Web Service. Now, Amazon as a cloud computing, you know, in 2006, Amazon Web Services began offering IT infrastructure services to businesses in the form of web services, now commonly known as cloud computing. One of the key benefits of cloud computing is that it gives the opportunity to replace upfront capital infrastructure expensive with low variable cost that scale with your business. So like when you have instead of having uh, infrastructure like a data center, so you can easily, like, instead of spending a lot of money on a data center, so you can just have the money that you have, you can just like give it to Amazon, and you can actually have like a certain space with them, so which is kind of pretty good because so it kind of like reduce your management capacity, and it kind of like reduce cost, and so you don't really need a lot of technical experts for you to like manage um, the the data center. So these are pretty good, and so it makes life easy. So with the cloud, businesses no longer need for to plan for and procure servers and other IT infrastructures weeks or months in advance. So instead, all they do is that they instantly spin up hundreds or thousands of servers in minutes. So, and it delivers the same result even faster. So today, Amazon Web Service provide a highly reliable, scale, low cost infrastructure platform in the cloud that powers hundreds of thousands of businesses in 190 countries around the world. So, and this is pretty interesting. So another thing that Amazon Web Service does is that we can easily use it for internet applications. So um, Amazon Web Service actually gives us a large platform of resources to help in our daily activities in nowadays applications, like Internet of Things, and pretty much everything that we can actually think of now that is related to technology. So it's really help us in that. So it's just like a virtualization of your applications, virtualization of your infrastructure. So the difference is the virtual server runs on top of a planet scale network managed by AWS, which is Amazon Web Service. So you can pay for your virtual server only while it runs with no upfront purchase cost or ongoing maintenance cost. So which is kind of like backed by AWS network. So using you can also use Amazon Web Service to build your internet application, which is like purchasing electricity from a power company instead of running your own generator. Like if you want to have your internet application like internet application that uses the internet, so all you have to do is just like pay the Amazon Web Service, and so you can easily run it on the cloud. And this actually provide many of the same benefit, capacity exactly matches your need. So you pay only for what you use. It's kind of like it's economized, and so its scale results in lower cost, and the service is provided by a vendor that is experiencing running large scale networks. So you don't have to like worry too much because they are very experienced in it, and it's kind of like makes your life easy. And now looking on how Amazon Web Service functions. Um, you can run nearly anything on Amazon Web Service that you would run on the physical hardware, ranging from websites, applications, databases, mobile apps, email campaigns, distributed data analysis, media storage, and private networks. So pretty much everything you can easily run on Amazon Web Service. So it's pretty good. So for as a small business owner nowadays, like if you're thinking of deploying your application, so you can just do everything with Amazon Web Service. So the services that Amazon Web Service provide are designed to work together so that you can build complete solutions to any form of problems that you're working on. So, and there are currently dozens of services with more being added each year. So, you have to be rest assured that Amazon Web Service have everything taken care of. And now, I'll be moving on to Data Warehouse. The first thing I'm gonna be doing is that I'll be talking about the history of the data warehouse. The term data warehouse was first coined by Bill Amon in 1990. According to Inman, a data warehouse is a subject-oriented, integrated, time-variant, and non-volatile collection of data. So these are kind of like data from different sources, but in their unnormalized form. So this data helps analysts to take informed decisions in an organization. An operational database undergoes frequent changes on a daily basis on account of the transactions that take place. So suppose we have a business executive that wants to analyze previous feedback on any data such as a product, a supplier, or any consumer data. So then the executive will have no data available to analyze because the previous data has been updated due to transactions. So a data warehouse provide us with generalized and consolidated data in a kind of like a multi-dimensional view. So, and along with this is a kind of like a generalized and consolidated view of data. A data warehouse also provide us there's something that we call OLAP, which is an online analytical processing tools. So, and these tools, what it does is that it helps us in interactive and effective analysis of data in a multidimensional space. And these analyses result in data generalization and data mining. So we have a data mining function such as association clustering, So classification, prediction can be integrated with online analytical processing operation online analytical processing. So and it's a form of operation to enhance the interactive mining of knowledge and at multiple level of abstraction. That's why warehouse has now become an important platform for data analysis and online analytical processing, which is really used in decision making, in business decision making. Like we can actually use it to like compare between the historical data, like okay, like you're trying to like compare what happened in the like 5 years ago to like the market trend of this current year 2017. So with the help of data warehouse, because it stores and it saves historical data. Actually, before even want to like you want to load it back to the operational database, you have to do some kind of a cleanup. But everything is kind of like saved there in the data warehouse in its normalized form, and so it's really help us to like get to the data anytime that we want it. So it helps us. Data warehouse details. Data warehouse actually helps us in in a lot of things, and so it makes our life easy. So and this is how it kind of like work. There's no frequent updates done in data warehouse. Like which is kind of like different from the operational database that you have to like do frequent backup, frequent updating to the operational database. Because but this is the data warehouse, which is analytical in its approach, and so what it does is that it uses batches updating. So that is what it's used. And so another thing is that it processes consolidated historical data. So like I said earlier, so that is what it actually does. It keeps information like past information. It keeps it in the warehouse, and so you can easily refer to it whenever you actually want to make a decision. You want to make it like a business decision, so you can easily get back to it. And so it's kind of like helpful. So and it's really helps the organization to analyze its business pretty quick and pretty easy. So and also, data warehouse helps executive to organize, understand, and use the data to take strategic decision. So it's pretty easy, like like when you have data from last year, data from 2 years ago, so you can easily like do some kind of like analysis on it, and you can actually make a decision. Like you can make a business decision based on this, and you can actually forecast what's gonna happen based on the data that you have. You can emphasize, and so you can do some kind of a prescription on what is gonna happen in the next couple of years based on the data that you have available. So we have a data warehouse also helping the integration of diversity of application systems. So uh, we have different kind of application right now, so it can also help us in like integrating different form of application system. So it does that as well. And a data warehouse system helps in the consolidated historical data analysis. So like it helps us like bring all the data together in one place. So those are things that it does. And it's used to extract data in periodic stages, or as they are generated. So you can use data warehouse to like extract data from the operation and database, and so which I kind of like make it efficient and simpler to process queries over data that came from different sources. So it's just like kind of like a combination of different sources of data that came actually into one place, and the one place is data warehouse. So the raw data is turned into high quality information to meet all enterprise reporting requirements, and also for all level of users. So all the data that is kind of like combined together in the data warehouse, like they kind of like um, the data is kind of like turned into high quality information. So it kind of like put it together, and meet all enterprise reporting requirements. So we also have, so why data warehouse? Now you might actually be wondering that, okay, why do we need data warehouse? We have operational database already. Data warehouse queries are often complex and they present a general form of data. So, an operational database is constructed for well-known tasks and workloads such as searching particular records, indexing. You can easily find information you want on the operational database. But data warehouse in its form, it's uh, it's kind of like complex and the present a general form of data for different sources. So like when we have a different kind of data, we have data from, let's say, the customer database. We have it from the employees database. Like everything kind of like from together in the data warehouse, and we have like a single form of a data warehouse that kind of like combine them together, and so we have like a single form of them, so that, and this kind of like help us in the decision making process. So we have operational databases support concurrent processing of multiple transactions. Concurrency control and recovery mechanism are required for operational databases to ensure robustness and consistency of the data. So, operational database query allows to read and modify operations, while an online analytical processing query needs only read access of stored data. So, an operational databases maintains current data, and on the other hand, data warehouse maintains historical data. So, and another thing is that data warehouse is optimized for batch write operations and reading high volumes of data that the operational database might not be able to do. So those are the reason why we need data warehouse. So I'm just gonna go over this real quick. The steps involved in building a data warehouse. So we need to extract and load the data. So what we have to do is that we extract it, and the data is being loaded into the data warehouse. So and this could actually be from different sources from different database. So and after that, it's cleaning and transforming the data. That data will be cleaned up, and it will be transformed. So and after that, we have a form of a backup and archive the data. So and managing queries and directing them to the appropriate data sources. So it's kind of like use a form of queries and direct the data to that their various sources. So, and these are also the steps in that we need in uh, data warehouse. So, which I'm gonna talk about right now. You want to collect and analyze business requirements, and you're gonna need to like build data model and data warehouse physical design, and at the same time you want to like define data sources. So you also select data warehouse technology and platform, and at the same time you extract, transform, you clean and load the data into the warehouse, and after that you select access and report tools that you actually want to use to make the report, and you select database access tools as well. So and after that you select data analysis and display tools. So and when you do that, so you can actually make a data analysis and you can just make a report from it. And after when you are done, so you update the data warehouse. So these are pretty much the steps that you're gonna use, and when you want to like analyze data being generated from the operational database. So the process that kind of like takes to extract the data from the operational database, and you can like load it into the data warehouse, and you can actually generate a report from it. So um, we have architecture of data warehouse. So this is how it works. You collect the data. After collecting the data, you store it. You store the data, and after storing the data, you process the data. And this process from is just like doing the analysis. So and it depends. And the fourth one is that you analyze and visualize the data depending on the kind of data analysis techniques that you actually want to use. So we have a different component of data warehouse on AWS. So because AWS, which is the Amazon Web Service, are actually provide us with multiple choices and with multiple platforms when it comes to data warehouse. So these are the three that I'll be talking about. We have Amazon Redshift, we have Amazon QuickSight, and we have Amazon Data Pipeline. So Amazon Redshift, like I said it already, like during in the introduction part, like it's a fast, fully managed data warehouse that make it simple and cost effective to analyze all your data using your existing business intelligence. So and as a small enterprise, you can easily have it, and as a big enterprise, you can have access to it as well. So and it makes life easier by you just pay for what you actually need, and you don't. I mean, um, yeah, it doesn't encourage waste of resources, so which kind of like makes sense. We have the Amazon QuickSight. Amazon QuickSight is a fast cloud-powered business analytics service that makes it easy to build a visualization, and it can actually use it to perform ad hoc analysis and quickly get business insight from your data. So it's just a kind of a platform as well that you can just integrate it into your data warehouse on AWS, which you can easily visualize. You know, you do a form of analytics, and so you can also visualize your data, so it makes the report easy. And we have the AWS data pipeline. So AWS data pipeline is just it's a web service in its form that helps you reliably process and move data between different AWS compute and storage services, as well as on-premises data sources. So it kind of like help in moving data from one source to another. So and it also helps in creating the complex data processing workload that are fault tolerant, repeatable, and highly available. So that is what it does. And I'm gonna go real quick on what Amazon Redshift provides for us. So it's optimized data warehousing, which means that Amazon Redshift uses efficient techniques and a variety of innovations in order to obtain a very high level of query performance on large amount of data sets. So it helps in optimizing uh, for data warehousing. So the second one is that it's scalable as well. What I mean by scalable is that the Amazon Redshift can easily scale in just a few clicks through the Amazon Web Service Management console, or by simple um, application processing interface. So if your organization actually requires a change, you can easily add or remove a number of nodes in your cloud data warehouse. So you can just be like, okay, you can just easily just do some kind of addition and there's subtraction on your on the application interface, and and it's still gonna be working as you want. So and another thing is that it's fully managed. To monitor its scaling and managing a traditional data warehouse can be challenging compared to like when you use Amazon Redshift. When you have your traditional warehouse, it's kind of like hard, but using Amazon Redshift to make life easy, and it has automatic data backups. It can easily upgrade and patches a service available by Redshift that helps you. and it kind of like focus on what is important and uh, to your data business. So another thing that it does is that you can easily get started in a minute. What I mean by that is when you use Amazon Web Service Management Console, you can create a cluster, define it inside security profile and underlying node type. The complete data warehouse for your organization will be up and running in no time. So like when you have it, so you can easily set it up. So and data warehouse houses are important tools to use in order to access business insight and analysis into your business operation, and you can have access to it anywhere. So compared to your traditional data warehouse that we have before, so this is highly flexible and it's easy to use. So and if you are migrating to Amazon Redshift, these are the strategy you want to follow. The strategy you should choose depends on several factors. So, which you can depends on the size of the database and its table. So you kind of like you want to like think about the size of the database and its tables, and also you think about uh, network bandwidth between the source server and AWS, because you kind of like need if like a platform to like get to the Amazon Web Server that will sound like a link, like a connection to the. So you want to know the bandwidth that serve as a source to the AWS, and whether the migration and switch over to AWS will be done in one step or a sequence of steps over time. Like when you are moving, you are trying to like switching over to Amazon Web Service. You want to know if it's something you can actually do at once or something you have to like switch over time. So you want to know about the data change rate in the source system, and also transformation that might actually happen during migration. You also might want to know the partner tool that you plan to use for migration and um, extraction, the ETL extraction, transformation, and loading. So, and uh, I'll be talking about these two step of migration as well, which is that we have initial data migration and the change the data migration. Initial data migration is the data is extracted from the source database, preferably during non-peak usage of to minimize the impact. The data is then migrated to Amazon Redshift by following the one-step migration approach described. So it's just like during the time it's not being in use, so it just migrate at once. And the second one is the change data migration, which is so data that change in the source database after the initial data migration is propagated to the destination before switchover. So it's just a form of when the data that kind of like change. So they are kind of propagated to the destination before switchover, and the steps synchronize the source and destination database at the same time. And so uh, the conclusion here is that, as you can see, a strategic shift in data warehousing as enterprises migrate their analytic database and solution from on-premise solution to the cloud to take advantage of the cloud simplicity, performance, and cost effectiveness. That makes life easier. So, like moving from the traditional data warehouse to the new data warehouse is it's something not everybody, all the small organizations and the big enterprises, something that they actually want to do right now, because it's kind of like flexible and it's more economical than the traditional data warehouse that they have, and so it could easily be deployed and they can easily use it. So shifting from the traditional data warehouse is something that uh, I myself I would actually encourage. So, and thank you.